Welcome back to our Chem 151 video series. In this video, we'll show you how to get empirical and molecular formulas by using percent composition. This question lists off a group of percent compositions and says if the compound contains those, find the empirical formula. The first step is going to be to use those percentages as if they were grams and change to moles. In order to change grams to moles, we will divide each of our starting numbers by the molar masses that we've been given. We'll begin with 49.47 grams of carbon, 5.201 grams of hydrogen, 28.84 grams of nitrogen, and 16.48 grams of carbon. Now this question gives you the molar masses right after the percentages. If you didn't know these, you could, of course, go to the periodic table. We're going to divide each of our grams by our molar masses. So carbon will be divided by 12.01. Hydrogen will be divided by 1.01. Nitrogen divided by 14.01. Oxygen divided by 16.00. If you divide these in a calculator, your carbon will come up as 4.119, hydrogen will come up as 5.150, nitrogen will come up as 2.059, and oxygen will come up as 1.030. All of these answers will be in moles. Now from this set of moles, what we're going to do next is divide by the lowest answer. The lowest answer in this set is 1.03, so we'll divide all of our answers by that. If we take our 4.119 moles of carbon, divide by 1.03, we'll get an answer of almost exactly 4. If we do the same thing for hydrogen, we'll get almost exactly 5. If we do the same thing for nitrogen, we'll get almost exactly 2. And for oxygen, we'll get exactly 1. Now, not every question you do with this process is going to work out neatly. Sometimes your answers at this stage will end up as decimal answers. You may have to adjust for those decimal answers. The decimal answers that you'll need to watch out for are any number that ends in 0.5, 0.33, or 0.67, or 0.25 or 0.75. If you have answers ending in 0.5, you'll need to take times 2 to each of the answers that you found. If you end in 0.33 or 0.67, you can use times 3 instead. And if you have 0.25 or 0.75, you'll use times 4 by each of your answers. If you have all whole numbers, there's no need to change anything. Since we have nothing but whole numbers, we don't need to multiply by anything at this stage, and our answer will have 4 carbons, 5 hydrogens, 2 nitrogens, and 1 oxygen. Therefore, our empirical formula is C4H5 N2O. We can follow this question up with a second question. If the compound has a molar mass of about 194 grams per mole, what is the most likely molecular formula? We can do this based on our empirical formula. Our empirical formula is known, but our molecular formula is not known. However, we do know our molecular mass, but we don't yet know our empirical mass. So what we need to do to progress this problem is try to find the empirical mass. Let's break this formula into pieces, using carbon, hydrogen, nitrogen, and oxygen. Now we'll note that we have 4 carbons, 5 hydrogens, 2 nitrogens, and 1 oxygen. We'll multiply each atom by its molar mass on the periodic table. We saw earlier that carbon's mass was 12.01, hydrogen's was 1.01, nitrogen's was 14.01, and oxygen's was 16.00. If we multiply straight across, we'll have 4 times 12.01 gives 48.04. 5 times 1.01 gives 5.05. 2 times 14.01 gives 28.02, and the 1 oxygen will give us 16.00. Then we'll add all of our masses together to get our empirical mass. We'll get a total of 97.11. So now we have to think about what do we need to do to go from 97.11 grams per mole up to 194. To do this, we'll take 194 divided by 97.11. If we divide this in the calculator, we'll get 1.99, which is almost 2. That means the most likely molecular formula is going to be our empirical formula times 2. So we'll take our empirical formula and multiply everything by 2. If we do this, we'll get C8 rather than C4, H10 rather than H5, N4 rather than N2, and now 2 oxygens rather than 1, and this is our most likely molecular formula. Thank you for watching, and we'll see you again soon.